The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The Metis Tech Show.
Mitsubishi.
Yeah, so we ate at the Portuguese Club last night, and it was excellent. They had good appetizers, had some good wine, the steak with the egg. Great.
Yeah, the wine hit me.
Did it really?
Reason. I only had one glass, but for some reason it got me, and I was driving home, and I'm like, wow, I can't believe how much that one glass,
All I
could feel it.
All I heard was Marcus finish the bottle. And they just kept pouring and pouring, and his glass was all the way up to the top.
Yeah.
I thought it was a lot less in that bottle, but it wasn't.
Yeah, I noticed that we're pouring, and then it just seemed to keep going, and then
They could have split that in between 3 glasses.
Yeah. Oh, for sure.
yeah. What did we get for apps?
We had the sausage.
Oh yes.
I don't remember the name.
Yeah, chorizo en bombier.
Yes, that's right.
And
Super
it's-
good.
Yeah,
Like-
what Brent said.
It's literally on fire.
It was on fire.
Yeah, they light it in this little boat and all that stuff. So that was pretty good.
We had the fish cakes.
Yes.
Those were pretty good. Tastes like crab cakes, but smelled like hush puppies. So.
Oh, really?
Did they smell like us? I didn't smell it because I'm not a big fish fan. If you guys remember, I like my food that walks, not swims.
It needs at least 4 hooves on the ground.
It doesn't have to have 4. Well, yeah, it has to have 4.
So most of us got the beef a casa, which is just a steak with egg, and it comes with the rice and the they call them Spanish potatoes or Portuguese potatoes, which is just like French fries. These were little discs, but I thought they were pretty good. I like the kind of switch up on it. And then I think Robert got octopus.
He did.
I can
he's
see
a
the little
maniac.
suckers on the tentacles.
He was like, I saw those suckers, and I was like, no.
Yeah, I'm all set. Thank you. Appreciate it. And then Marcus, you got a burger, you said?
Man, it was a burger
Yeah.
with bacon, eggs, and a pineapple, a grilled pineapple.
Grilled
The
pineapple.
pineapple. That was.
Is that what got you to get the burger? Was the
Yeah,
pineapple?
It's the pineapple.
Yeah. Do you like pineapple in
I
general?
love pineapples. They're juicy,
Yeah.
taste like sugar.
Yes, I love
Pineapple on pizza or no?
I don't do pizza.
Oh, that's right. You don't.
Only if it's
forgot.
only
I
pineapple.
Only pineapple and sauce.
Can I get a Hawaiian pizza? Hold the cheese.
They make those.
Yes, they do. Yeah. But yeah, it was pretty good. And then they offered the espresso, which I did not take. I
Yeah.
probably should have.
I didn't.
Probably would have leveled out the one glass of wine I had, but I'm a big espresso guy. When we went to Italy, that's what they do. After every meal, they offer you the espresso. And I'll be honest with you, there was I was on a kick of it for a little while because it does just kind of
Lift you up.
well, not so much lift you up, but it just levels out everything you ate, and you leave there with more of a neutral palate, and I didn't feel energized afterwards, but it just kind of settled everything that you just ate, especially if you have a bunch of unique flavors and stuff. So I just kind of reset my body. And I'm telling you, they talk about it, and everyone always says oh, when you eat food in Europe, it's totally different. It's totally different,
Yeah.
and it's shocking how different it is. I was not a believer in that. I'm it's just because we eat too much because we have so much food around. I ate normal. I didn't try to eat health conscious when I was there. I just ate when I wanted to eat, and I just never felt that weight. You ever eat a meal in a U.S. restaurant, and then you go home and you're oh my gosh, my stomach hurts, and you're kind of just dragged down. Never experienced that there.
I've been in a food coma before.
Yeah.
Believe it or not. Left a barbecue restaurant, and I had to call a buddy, and it's hey, dude, you got to come get me. I can't drive.
The one time that happened to me was the first time I went to South Carolina.
Really?
Yes.
Must
So
have
I
been pork.
no. So I was. This was years ago. So we didn't have Raising Cane's up here yet. So I was Raising Cane's. It's a southern fast food restaurant. So didn't really realize how big of a chain it was. I thought it was more local. So I had it and had the tenders and the Texas toast and the crinkle fries and all that stuff. And then immediately afterwards, we went to this place called Crazy Mason. where they make a milkshake inside of a mason jar, and after you get to keep
heard of
it,
that place.
you get to keep the mason jar. But these aren't just like, it's a chocolate shake and you sip it and go. It's a chocolate shake, but then they'll crush up chocolate-covered pretzels and put it in there. The whole thing has a drizzle of caramel syrup.
Oh my God.
And chocolate syrup, and then they shove your spoon or your straw in there, and then over the straw was a full brownie.
Oh my goodness.
With more pretzel pieces. Literally, there were
That's too much.
1,500 calories in a single shake.
That's crazy.
So we went straight from Raising Cane's right to this place, and afterwards, I sat on the bench outside that shake place, like, oh no. I just immediately
Don't know if I can get back
tired,
up.
exhausted,
Yeah.
and I was like, let's just go to the airport early, and like,
He's like, I'm done.
I'm done. I was wiped.
He said, find me a pillow and a blanket. He
could
said, I need
not
to curl up.
could not believe how tired I got immediately.
Well, cool.
But anyway, welcome everybody to the Metis Tech Show. I'm here with Will, which is our Orlando trainer or instructor, Marcus, our Chicago instructor, and Ralph, our resident M&P expert. And what are we talking about today?
We are talking about the electronics diagnosis on P-Series, how it's changed.
Yeah.
It's changed a lot.
Yes. And we're finding this, I think, more and more as time goes on, is that, we've already done a podcast called What We've Learned
Exactly.
with the A2L equipment, and we're still learning more. And it is, like you said, changing the way that we have been doing things for a long time. So it's good to keep updating on these things when we find them.
Yeah, I thought it was important to get this one out here.
Yeah.
Because guys are going to waste so much time misdiagnosing. They're going to go change a board, and all of a sudden, oh, it wasn't a board. And they're going to say, well, I'm sorry, Miss Smith. I got the wrong part. And
I know we just waited 3 weeks.
yeah, we just waited 14 days. They gave me the wrong part. Now I got to, it's going to be another week or so before I get back out here. By the time they're done, that lady's been without air for 14, 21 days, a month.
Yeah. And
Yeah.
that's
Yeah.
it. And you're, in trouble. And obviously the big thing too is that we as a manufacturer are trying to limit how much we have parts that get warranted, and then we
Right.
find out, we're replacing perfectly good parts, and it's just because the diagnostic procedures aren't being followed or aren't known yet.
Right.
So this is kind of collaboration with Ralph and Austin Bloom, one of our tech support
And Ed Fish
folks,
as well. Because
and- Yep.
Yep.
And so a lot of our guys, they discover the things in the field that, as instructors, we go off of manuals, right? We talk about what is in the manual, and we get really good at that.
Yeah.
Our service team is great because they do this is what actually happens when applied in the field. And so between the two of us, like, we get a lot of answers. And so this is kind of an example of that. Well, we'll go over a couple things that we've learned from being in the field, and then just kind of going through what we do in the training centers, which is break everything down, see how far we can break it, and get some answers.
Here's what people don't think about, as far as we go. So the area service managers, they only talk to DSGs, right?
Yeah.
Well, we are physically talking to the contractors.
Yes.
So if we can get that information to the guys in class first, then it's a lot less phone calls for the ASMs and tech support.
Yep, that's a good point. So let's start with probably the simplest one to talk about, which is our LEVs
Yep.
with the A2L equipment.
So you want to do it?
Yeah, sure.
All
I'll
right,
do
so
it.
go ahead.
Yeah, so we've just had some basic changes with our LEVs and the power heads. And on some of the equipment, you'll find a twist-off LEV power head, and you may still find the old clip-on style.
Yes.
And if you try to pull off one of the twist-offs, you're going to break it.
Yep. If you're lucky if it just bends.
Right.
Because then you can just bend it back in place and, oh man, when did they change this? And then
Right.
put it back.
So there'll be a thin tab
Yep.
that's mounted on there, and it screws over the tab,
Yep.
and that's what locks it in place. And it stops at a certain depth where the head is supposed to sit properly on there, so
Yep.
it's properly mounted.
What it is the head itself has a little slot in it where that little piece of steel, as you turn that LEV head, that piece of steel fits in that little slot and it keeps it from coming up. Because what was happening, and I don't know if it was because we changed factories or if they was like, oh, sometimes we would get a unit back and that LEV would be unclipped from the actually the head would be unclipped from the LEV.
Right.
And then the unit would pump down, and then the guy detecting the field would, I don't know what's going on with this thing. This thing's a piece of junk. And then, of course, everybody's yelling at everybody, and the whole time it was just the LEV was unclipped.
Yeah, I've seen it in the field.
Yeah, I took a million phone calls.
I've also had the ones with the twist off, and the first time I ever had one, I broke it.
Really?
Yeah, immediately.
Yeah.
The guy was like, "Hey, take that off real quick and test it." And I was like, "Yeah, no problem." I stuck my arm down in there, didn't pay any attention. I was like, "It just pops right off." Stuck my arm in there, and I went, and boom, snap, came it off. You know, and I was like,
Yeah.
I was like, "Hey, is this? Can I fix? Is this? Can we fix this?"
Yeah. How do I make this work again?
Zip tie it. You have to zip tie it back in place.
He was like, "We'll figure it out."
Yeah. But that's one of the things, though, is because even with those clip-on style, like with the moisture that can get in there sometimes, they can be kind of tough to pull off.
Yep.
Yes.
And so you don't think twice about giving it like kind of a
course,
firm tug to maybe break some of the corrosion loose inside those, where those teeth are inside the power head. And so you don't really think twice about it, but it's just worthwhile to actually take a look and see if that clip is in place on that, you know, smaller port coming out of the LEV, and maybe it might be a twist off. And I forget, I think it was Austin who told me it's like a 90-degree turn. So it's like a 90 degree to pop it up, and then you drop it back down 90 degrees to lock it in.
That clip's only like a half an inch, 3/4 an inch, somewhere in between there. It's not very big. But what you do have to do is you have to take the wires, cut the wire tie off, because the wire's holding holding you from moving it.
Yeah, yeah. In some cases, I know the one I tested it on, I was able to do it,
Right.
But it might just be unit specific.
It's depending on which unit you have.
And it's the same like anything else, lefty loosey, righty to tighty.
Because when I was in Swanee, Austin was actually the one that showed it to me, and we went to one of the units in the training room, and we was able to get it off. But then in Dallas, I looked, and that unit had a zip tie on it, and I couldn't turn it without cutting the zip tie.
Yeah. And then it makes you wonder, did Austin already cut the zip tie when he?
No, I don't think so. No, because we actually went in, and this is going to go on to the other subject we're going to talk about.
Yeah.
We actually went into the training room for a whole different scenario.
Yeah.
And then he was showing me that while we were in there.
Yeah. Yeah. So yeah, general rule of thumb, just double check. It's still possible that you'll see some of the pull tops where there's just the clip holding it in place. But we do now have those twist style on the A2L equipment. So just look before you start yanking on LEVs, because it's way easier to just take 2 seconds to look than it is to replace it.
Yep.
And have one that doesn't seat properly anymore. So just do your due diligence there.
Man, if I had to replace a LEV, I'd be buying another one. I don't want to have to mess with it.
So that was one of them. Pretty simple. Let's go into with some of our equipment and how refrigerant sensors can affect the diagnostic process. Because don't even want to limit it to the refrigerant sensors, but some of our safety features, some of the new safety pieces of equipment or parts that are on our units, they can affect some of the ways that we diagnose certain issues. So let's start with the one that you were talking about this morning, Ralph, related to like a PAA, I think it was the original, how it got found.
Yeah, so what happened was somebody installed a PAA coil, IntelliHeat coil, and the sensor, if you guys aren't aware of it, on our board, there's a blue connector, and our plug is blue, right? Well, it's the wrong connector. It's numbered wrong, right? So normally we say our connectors and plugs are always the same color.
Right.
Yeah.
Well, sometimes they're not. You just got to pay attention, and then you have to look at the number and make sure you're plugging in the right spot. But mostly everybody just takes that blue plug or connector and plugs into the blue plug. Well, if you do, you're going to get a sensor error. I did in Dallas when I did my install.
Yes.
Right.
And Rob did in Atlanta.
Everybody, we all, unless they got the phone call.
Right.
Well, so when they moved that sensor to the right connector, somehow it shorted. Whether they had power on when they did it, probably. I'm almost going to guess the power was still on when they unplugged it.
Sure.
But what it did, it shorted the sensor. And then they had steady DC voltage on S2 and S3. And normally that means you have a bad board, right? So what they did is they changed the board. Well, when they changed the board, guess what?
Same problem.
Same
thing.
problem. Nobody ever thought about looking at the sensor, so they got a whole new coil because they're like, that's always everybody wants to change the equipment itself. So once they got the coil, Ed Fish, the area service manager, was like, "Hey, why don't we take the sensor off that one? Because the board didn't come with a sensor, but the coil does. So they took the sensor off the board, off the new coil, put the new sensor in." And guess what started happening? We started getting a 12 to 24 volt pulsating.
Yeah.
So we have to be careful and look at everything. Just don't look and say, hey, I got 21 volts here or 24 volts steady, so I have a communication error. So now I have to change my board. No, we got to basically go extra steps now.
We need to diagnose.
Yeah. So that refrigerant sensor, we tested it
Right,
this
we
morning,
tested it this morning.
and we put a short in it. It's the luxury of being able to order replacement equipment.
Yep.
Is we get to test these things. So we shorted the refrigerant sensor, and it was kind of funny because we had our little jumper, and when we had it jumped, immediately we lost the communication.
Yep.
When we took it off, communication came back. We put it in, we lost communication, took it out, communication came back.
Right.
So, and it was immediate.
Yep.
Almost immediately. And so we did test it on a PAA, but I can almost guarantee it's going to be on everything.
It's got to be.
Because even in your case, we had it on a PUZ or an SUZ, and they were having the same
Yeah,
problem.
that was the original thing. Well,
Yeah.
they had an SUZ, and then they said, well, that unit's not compatible with that IntelliHeat. At that time, it wasn't.
Mm-hmm.
And funny story is, a week later, that SUZ was compatible with
Yes.
it. It came out to where the testing was
The
done.
downside to waiting on ratings.
Exactly,
But-
exactly. But now, before we go on, so if you do have this problem and you have 21 volts, disconnect your sensor and see if your volts comes back on your pins, on pin 1 and 4. If it comes back on 1 and 4, then you know that, hey, there's something wrong with the sensor.
Right.
Because you may not get a sensor error with that short.
Right, especially across 1 and 4. And the reason
Right.
why is because that actually powers that sensor. And so if you have no power to it, it doesn't have the ability
Right.
to communicate back. And so it may or may not. I mean, in our case, it did
Right.
show an FH error, but it may not.
It may
So
not.
just
Right.
be
Well,
aware.
I think because we had the power off and it
Right,
turned
exactly.
power. That's what,
So in general, with all of our refrigerant sensors, it does not matter which unit. Not all of our refrigerant sensors are the same. Our ducted unit refrigerant sensors are different from our M series refrigerant sensors. Our PAA is different from both of those. So we have really 3 different main refrigerant sensors. But from our control board on the Mitsubishi board, coming off of our control board on pins 1 and 4, universally is 5 volts DC.
Right.
And so that is what is powering that little PC board that contains the sensor. That is where we could check for that short.
and our 2 and 3 is our communication.
Yeah, there's some sort of serial communication going back and forth between those boards. But just basic diagnostics of a refrigerant sensor, see what you have for output voltage coming off of your board. If you had 0 volts coming off of pins 1 and 4 from the board, I'm not necessarily condemning the board right away.
No.
For the same reason we just talked about.
Yep.
You don't know.
What
I
does a short
think
do to DC voltage?
is that short. I think that short is not. It's not enough to physically cause a problem with the communication volts. It's just enough to cause enough draw to where it's steady.
Yeah. So, and obviously, without the fluctuating voltage, no data transfer. We're running into problems.
Yeah.
But yeah, so typically, if you have 0 volts off pins 1 and 4, that does not mean the board is bad, because with that connector plugged in, if there is a DC short, it will show 0 volts. So next step would be what you said, Ralph. You can either unplug it and see if that voltage restores on the pins coming off the board. Another check to do that would be quick is just continuity across pins 1 and 4 on this sensor.
I would check. I would still double check just to make sure.
both.
Because if you just mount the sensor and you order a new sensor and you don't double check your voltage coming off your board, you still may be buying another board.
100%.
You
Especially,
still may spend another week with that lady not having air.
yeah, especially because DC shorts like to take out more than one
Exactly. There could be a little fuse, a little capacitor, a little transistor
Something.
that messes up on the board.
Salt and fuse.
Yeah, exactly. Soldered in fuses. So ultimately, I think the big takeaway there is if you have odd indoor unit communication voltage, if it's not fluctuating and you have some sort of steady voltage, double check your refrigerant sensor before you condemn a board.
Yep.
Yes.
That's the thing you got to do. And what I was actually mentioning before was with the compressor protector on the M series.
Oh, yeah.
It's another safety feature that was added for A2L, and it also does something odd to the communication. Right. So if we have that compressor protector, once it hits 248 degrees, that switch opens. It doesn't start looking at that compressor protector until the compressor is turned on, which means it could be showing open. It could be an open switch, but if you just power it on, you still have fluctuating communication voltage.
Right.
But then the compressor starts, it starts to look at that compressor protector. If it shows open, it will shut the compressor down and slowly lower that DC voltage down to what I've found every time is about 4.5 volts DC. And so, again, think about from a contractor's perspective, they've been working on Mitsubishi for years. They see 4 volts DC at the outdoor unit.
Got a bad board.
Bad board. Now, they may take the extra step and say, you know what? Before I condemn the board, let me power down, take my wires off, and then power back on and check S2, S3. Here's the problem with that. When they do that, the voltage is back.
Right.
24 volts DC.
Yep. Because they pulled it off.
So then they're going, what is going on? They're losing their mind. So just be aware that if you start to see these weird communicate, for some reason, a lot of our safety features are tied into that communication bus. So just be aware that you might see some funky voltages. Keep in mind some of those refrigerant safety devices.
So that's the nice part about if you didn't come to class or you didn't listen to the podcast, you would never, ever know this.
No.
Because it's not in the manual.
No. In fact, when you get an E6 error code, which is what that will cause,
Communication error,
because it
yeah.
goes down to that 4.5 volts. In the E6 service manual, when you look up E6 in the service manual, there is no diagnostic step that says check your compressor protector, even though that is a cause of an E6.
Right.
So these are the things that, I did at the DSG conference. We try our best to get it out to as many people that need it, but it's never going to be everybody.
No,
so.
it's never. I mean, there's no telling how much money we spend in boards a year that are good. They're just going in the landfill.
Yeah. So, but yeah, that's another great point. Good thing to check. The last one we wanted to bring up was related specifically to P-series equipment.
Yeah.
Although it may occur on other pieces of equipment.
Right. We just don't see it on other pieces because they're one boards generally.
Single board systems, it doesn't make as much of a difference.
Let me tell you something.
But the P-series multi-boards.
This one here drove me nuts for days and days because I tried everything I could possibly think of to try to figure out what is actually happening with this thing. But then I just kind of conceded to where that's beyond my pay grade. I don't need to know all that. And I just need to know why it's happening or what's happening and how to diagnose it.
Yeah.
And that's it.
So on that note, why don't you guys go through standard diagnostics? So what we've always done when this scenario occurs.
So what I'll do is I'll ask you guys. So let's say we walk up to a board and it's not working and you test S1, S2, or S2, S3. How many volts should we see it in between S2 and S3 on any given time? If the unit, let's say it's working right.
Fluctuating voltage.
12 to 24 fluctuating voltages. Okay.
Good.
So now let's say we had some sort of communication error. What kind of voltage should we see in between S2 and S3?
Yeah, you'll just have a steady voltage.
Just a steady 24 volts, somewhere around there, right? It doesn't have to be. It doesn't have to be. It could be 21. It could be 24. It could be 29 volts
Right.
for all I care.
Yeah.
But it'll be steady.
But just as long as it's steady, right? So that's so if we had 29 volts, just a steady DC voltage, now we say, where's our problem?
Right.
Our problem is in between where? The outdoor and the indoor, right? So it could be in the wire, it could be in the indoor board. So most people would be like,
It's a board.
it's a board, right? Without going any farther. So now what they're going to do, they're going to order a board. This is why it's so important to have these podcasts and talk about this stuff in class, because now with the new P series, with the new logic, and it's got to do with something with the sensors. I don't know what it is and don't even care.
Right.
Don't care because I'm done driving myself nuts. I even was like, I'm going to take this board. I'm going to get a board. And I'm going to send it to an electronics company, and they're going to take it apart. And they're going to
Tell me why.
Tell me why this is happening, right? So now what has changed is if you lose your 300 volts DC, and this is where our communication volt starts. It starts at our power board with a 300 volts DC. It goes into our control board and through processors and stuff like that. Yeah. Then it comes out of S2, S3 as our communication voltage. That's where that 12 to 24 volts happens, right? Well, now if you lose that 300 volts DC from your power board and you go to S2, S3, you still have 24 volts there. Wow. So it's still a steady DC signal. So now, if you walked up now and put your meter leads on S2, S3,
24.
and you see 24 volts or steady DC volts, what are you going to say?
Yeah,
Oh,
you
it's got a
still
bad
go
board.
through the
It's
same
got a bad board.
diagnostic
It's got a bad
process.
board.
You would be checking your wires, and then you'd be checking the indoor board, trying to figure out
Right.
what between the outdoor unit, which is supplying the proper voltage,
Yes.
and my indoor unit has gone wrong.
Exactly. So, but now here's a kicker. Here's where I was like, oh, we've been diagnosing this stuff all wrong this whole time. So if you disconnect CNAC, which your AC voltage from the noise filter board, you lose your voltage. So I was like, oh man. So what's happening is somehow, if you lose your 300 volts DC, that AC circuit still has diodes and transistors in there that's just going to send it steady 24 volts to the indoor. And we need that because of whatever logic changed. And it's got to do with the sensors,
Something
because
to do with
why else
mitigation.
would they do it?
Yeah, it's possible. The big thing, and this is actually was really interesting. This is why I love Felix so much, is because yesterday I asked him, I'm like, we had one of those door switches.
Yeah.
And in the door switch, I look down in it, and I'm like, I see a diode on this little plastic housing, and it has a diode symbol on it. And I'm like, oh, it's one of those things where it sends light to a sensor, and then when you block the light, it opens the switch. And he's like, and he knows exactly what it is. It's a photovoltaic sensor. And I'm like, yes, that's what it is. And so that's what he's awesome for. And so same thing happened here. I was like, it's still got the 24 volts. And he had made a good point, which is that it's possible that the AC voltage, because he says, when he says things, it all makes sense. But he's like, the 24 volts is we're just using the voltage to move the data back and forth.
Yeah.
Right.
So the 24 volts can easily be made by the AC voltage coming in, the 24 volts DC, but there's no data laying over it because that's on the 300 volts DC side. And I'm like,
Yep.
You want to hear
why I
something
love it so
cool?
much.
If you look above S2 and S3, there's a big orange capacitor. And what that capacitor is doing is taking the AC voltage coming back from S3 and sending it to ground. So that's how it filters out the AC DC, and then it goes back into the board as DC.
Right.
So, yeah, I thought that was pretty interesting. And really what it's doing for the contractor is when you see that constant 24 volts, don't immediately start thinking indoor unit or wire problem.
Right.
Because you're already at the outdoor unit, I would say just real quick, check your 300 volts DC. See if it's
100%,
there. If do you have LEDs on the board?
Right.
If there's no LEDs and you have 24 volts,
That's
And you
well,
got it.
careful.
There you go. So here's the deal. So if you walk up and you have 24 volts on S2, S3, but you have no LEDs on the board, so they're not lit, that is a outdoor problem.
Right.
But if they are lit and you have 24 volts, now you have to go
Start
inside.
hunting
Start looking
inside.
inside.
Right. So it could be a sensor. You know,
Right.
so that
Could be a sensor.
who knows?
It all
Who
ties
knows?
together.
Everything ties together. The whole purpose of this podcast is to make sure you guys understand that we have to start looking farther into it, and get the tools off the truck, and do a couple
Actually
extra
test
steps.
Yeah. And don't be shy about testing.
No,
Yeah.
Like if you gotta power down, unplug something, and try again, like just don't,
it.
Just give it a shot. You'd be much better off knowing exactly the behavior to be able to isolate it.
Right.
Even if you do end up calling your DSG or your service team, you're like, hey, this is what happened. I unplugged CNDC. I still had the 24. That's the kind of stuff that service managers love to hear and DSGs love to hear
but
because
like,
it
that's great.
limits what's actually
Well,
going
you
on.
know what? Here's a thing about that though. Some of our employees don't even know this.
Right.
It
We're
is
all
very
still
Right.
new.
We're
It's
all
very
still
new.
new at this. But you know what? Here's if I can give anybody any advice, do not be afraid to let the Japanese magic smoke out of these boards, because that's the only way you're ever going to get good is by letting enough smoke out of the board.
Yeah.
Yeah, trial and error.
Yeah,
and,
it
and in a
happens.
perfect world, somebody else has already done it.
Yeah,
Right.
exactly.
So,
So
then
you
don't
learn
have
off
to
of
do it
somebody
yourself.
else's
Right.
experience, right? Yeah, learn off my experience, not
Yeah.
don't
And-
create your own.
And to be honest, that's what we do. I mean, we don't necessarily always blow boards, but we do test things all the time. When Ralph brought up some concerns and some things that we've been talking about this through this podcast. We tested everything before we started. We actually went to the units. We shorted out the refrigerant sensor. We actually, pulled CNDC, and it was just for us to verify the information. Are we electrical engineers? Are we geniuses on the circuit boards? No. But we have the ability to really get our hands dirty on that stuff and test some of the things that we're hearing and seeing in the field. And it's great because it gives us the ability to explain on the contractor level, here's how to fix this. You know, don't worry about all the stuff
Don't worry
that can
about the
get
magic
really
smoke.
confusing.
The best advice.
We'll try to take care of that for
The
you.
best advice Rick Powell ever gave me, because I was asking him, well, how come this does this and this does this? And his best advice was, why do you care? Why do you care? Are you gonna go out there and unsolder that transistor and put a new transistor in? I was like, absolutely not. Then why do you care? Why do you care? All you need to know is where voltage comes in, where it leaves, and what it's supposed to be when it comes in and what it leaves.
Yes. Now, in a pinch, on like a furnace board, have I soldered in like a new fuse?
of course.
Or,
Yeah.
I mean, I have, but
It's happened.
that's more like this was actually really common during COVID. So I was still in a van during COVID, and because of supply chain stuff,
Yeah, it was bad.
I could get on Amazon and get a 100K resistor
Right.
way faster than getting a new board. And so there were times when I did do these things, but it was mostly just because I'm like, it's either this or we wait 6 weeks to get a board.
Right.
Well,
Yeah.
I would still get the new board and take it back.
Oh, 100%.
And the reason why
Of
is
course.
because when you start doing that kind of stuff, now you assume the liability
Oh, yeah.
of
the board,
what you've done.
100%.
And if something happens, if there's quote unquote what the legal field calls a thermal event, not a
Right.
fire, but it's called a thermal
Oh,
event.
of course.
So if that happens, there's 12 guys, and this is no joke. There's 12 guys standing out there wanting to figure out where that finger gets pointed to.
Well, and that's the thing, and I talk about it with even thermistors. Is like if you have a thermistor, let's say you're looking at maintenance tool, and you have a thermistor that's reading a super, super cold temperature,
Right.
really cold temperature. That means that the resistance is really high. In fact, it might even be infinity,
Yeah.
which means you have a broken wire somewhere. So I'd say, can we fix a broken wire in the field? 100%.
Yeah.
We can put a broken wire back together. However, you should still order the replacement thermistor, but you don't have to take them out of service while you wait for one, for something like that.
When guys ask me that question in class, hey, is this a 10K ohm, a 20K ohm thermistor? You know what I tell them?
What's that?
Well, we can't cuss on here. But but what I do say is I don't know and I don't care. Yeah. Because I'm always going to go to the manual because I feel like if I tell them, oh, it's a 10K ohm, I'm going to start carrying a bunch of 10K ohm thermistors in the truck.
Yeah.
It's not going to do you any good.
On that note, just because you brought it up, we're getting off on a tangent, but it's okay. So I don't know if this is all thermistors, but what I thought was very interesting was I was in Italy doing a training, and the rating on those thermistors, so a 10K ohm, 100K ohm thermistor, the way that they get that name or that naming convention is that is what that particular thermistor will read at 25 Celsius.
Right.
Right.
That, which is 77-ish
right,
Fahrenheit. But that was like, it blew my mind. I'm like, I've always wondered like why they call them 10K, 100K. What is the actual meaning behind? Like, I know it just means more resistance or less resistance, but it's actually a rating against 25 degrees Celsius. That's where you'll see that reading. And I'm
I'm
like,
just going to
no
look.
way.
Yeah, I'm just going to look it up. I don't have enough time or
And
mental.
listen, our thermistors don't even follow that.
He's like, don't take that one with you.
But you know what we did learn today during our testing and stuff is that brain could become part of communication. So
That is
Yes,
correct.
I did.
He became
temporarily-
a part of the communication circuit.
Yeah.
just for a second.
Yeah, I felt it too.
Oh, yeah.
I felt one with the machine for about half a second.
Yes.
I'll throw one related, but with the City Multi equipment, I found that the LEVs that we're now using for our safety. So we used to have solenoid valves A, B, and C. We're now on LEVs L, A, and B. And I've always wondered, I'm like, my experience always throughout all manufacturers is that the solenoid valves tend to be a little bit more reliable than the LEVs.
Yeah,
I
sure.
replaced more LEVs than solenoid valves in general. So I was like, it's interesting that they would use those as a safety device because of they're more prone, not prone, but more prone than a solenoid valve. But in Advanced City Multi-Class, I tried to close one using maintenance tool and then unplug it so it showed a restriction
Right.
and throw an error code.
Really? Oh yeah, because that's part of the.
So
Part of mitigation.
I think that to me it makes sense that they can get feedback with an LEV that they might not be able to get through just a solenoid valve open close signal. There's actually some feedback they can get from those LEVs because I got a 6841 as soon as I unplugged it.
You know, a lot of people are like, why do they make these changes? But there is a method to the madness.
There is.
I mean, there is.
It's usually people much smarter than we are. We are making these decisions.
Electrical engineer, he figured this out.
Yeah.
Yeah, they're in a whole different brainwave.
It's actually part of what makes it fun is that all of us have been in a van at some point in our lives.
Yeah.
And so it's kind of fun to just be the guy that's trying to figure out what these
what's
geniuses are doing.
I'm done second guessing it. I'm just like, well, I say I am, but I spent days and days trying to figure out that communication circuit.
Yeah.
Right.
Yeah.
But
Yeah. Awesome. All right. Well, I think that wraps it up. I don't think we had anything else. I think it was just those big 3 ones that we've learned since, and we threw in some extras.
Yeah.
Very big
it's almost
things.
Good stuff.
It's good stuff to know because otherwise we'll get
How are you
good
going to
boards
know
back.
if you don't hear it here?
Yeah.
You know,
That's a good point.
I want to throw out, thanks to Austin
Yep.
Oh yeah.
and then Ed Fish, actually. For
And Ed Fish. Yep. Thank you. And this is our last day for the team meeting, so you guys are all flying back tomorrow.
Flying back.
And we're doing Red Heat Tavern for dinner, which is like an American restaurant. It's I think you ever been to like a 110 grill? I don't know if you guys have them up by you, but or like a Yard House.
Yeah.
You're at a Yard House. It's kind of like that.
It's like Miller's Ale House, kind of.
Very similar, yeah. So it's like a American food, but tons of different options. So usually nobody feels left out.
Yeah.
We've got our non-pork options. We've got our non-cheese options. We've got
The dairy's huge.
Non-fish options.
non-gluten options for Rob. So it's like everybody gets their cuisine and their dietary restrictions taken care of. So, but it'll be fun. Do our final shebang, and then you guys all fly back.
Part ways.
Walk that.
Yeah, I got a
Until
3
next
o'clock
time,
flight or
Yeah, we're going
3:45.
Around the same time.
I'm not getting home till 9 o'clock tomorrow.
Okay.
It's about time I'll
9:45.
be there.
Yeah. Have you ever tried Delta?
Normally, I have a direct flight. Something happened. I changed the filter. Normally I put nonstop, and
It happens.
and it's
Got a connection.
the worst one is when you do AM PM.
Oh yeah. Yeah.
I've done that before. I've done a PM instead, and didn't get to the airport till 2:30. That was terrible.
Yeah. That's
And then they gave me a Mitsubishi Mirage.